This is February March 0625 Physics Paper 1-2. The first question says a student has a measuring cylinder containing water and also has a balance. Which one of these should she use to find the volume of a small metal sphere? She has no other apparatus or no other choice. So either the measuring cylinder containing water or the balance, measuring cylinder containing only, balance only, neither measuring, neither balance. Now, the beam balance or the measuring balance, as you can say, was actually used to measure mass. Now, since the person only wants to measure volume, we only need a measuring cylinder to do that. So that will be a very clear option B for this matter. Question number 2 suggests we need to find the resultant of these two forces. Now, the resultant is the effect of all the combined forces. A very easy question, straightforward. We have 4 Newton to the right side and 3 Newtons to the left. This is your right side and this is your left. So what are we left with? So the resultant force generally means what are you left with? What's the end goal? What's the end product? So again, the dominating force, which one is greater, minus the not so dominating force, or the force that is a bit less than the other one, would get us this answer. So the resultant force represented as Fr will be equal to 4 minus 3, which is going to be 1 newtons, but in the direction of the dominating vector, the direction of the dominating force, which will be the 4 newtons. So whichever is greater, the block would eventually be feeling a resultant force in that direction. So it should be the right side. Again, option B would be the right answer to go forward. Question number 3, a ball is falling towards the ground, which transfers of energy or store is taking place. So the new thing for 2024 and beyond is that they don't want to use the word forms of energy or types of energy. They will be using the word stores of energy, because we know that energy can neither be created nor it can be destroyed, but it can change from one form to another form. So keeping in line with that idea, we will be replacing the word forms with the word store. But anyways, let's get to this question. A ball is falling towards the ground, so primarily it has gravitational potential energy, which is converting into, or we can say it is being taken from the gravitational store or being given to the kinetic store. So a very straightforward answer would be from gravitational potential energy store. Again, they should add a word store here, and to kinetic energy store. You can do this for your P4 theory questions, and I would advise you to use these terminologies. Question number 4, he says, which quantity is a scalar and a vector? So just to quickly write down which one of them would be scalars and vectors. Energy is a scalar, mass is a scalar, momentum is a vector, and distance is a scalar. Velocity is a vector, time is scalar, weight is vector, temperature is also a scalar. So keeping that in mind, one of them has to be a scalar and the other one has to be a vector. That will be very clearly option A. Question 5 says, table gives the data about 4 liquids. We have liquid W, X, Y, Z, so and so forth. We have mass and volume. So most likely the question might be regarding densities, or might be about densities. Who knows? We will get to the question. So none of the liquids mixes with any of the other liquids. So they are not going to mix together. They're going to form layers. All the liquids are put in the same container and settled to form 4 separate layers. So it might be possible that in the container, when all of these liquids are added, the liquids are separated by layers like this, so on and so forth. So the most dense liquid will settle at the bottom, and the least dense will be floating at the top. And of course, the middle layers would have other liquids that have probably densities in the middle or a bit less, so on and so forth. So let's try to find out the densities. Now let's look at the question. He says, they put in the same containers. Which statement is correct? And they are in 4 separate layers. So it is from the topic of principle of floating objects. The most dense will settle at the bottom and the least dense will be settling at the top. So let's find out the density of each of them individually. So that the formula would simply be mass divided by volume. Mass is given to you, volume is given to you. So simply keep dividing all these quantities with each other and you'll get the answer. So for the first one, we have density as 1.0 grams per centimeter cube. The second one has 1.3 grams. The third one has 0.6. And the last option has 0.8 grams per cm cube. So if I were to organize this in this container, the smallest density is Y. So Y would be at the top. the next liquid would be Z in the lineup, and the green one should be density W or liquid W. The last one, or the heaviest one, or with the most density, that would be liquid X. Now we're going to put in the statements he has given us into this checklist and see if these are correct. So he says W forms a layer below X. Is that true? No. W is above X. X forms the topmost layer. Y forms the topmost layer, so this is also incorrect. Y forms the bottom layer. No, it's X that forms the bottom layer. So Z forms the layer above Y. Forms the layer below Y, sorry. And that is correct. So this is option D, as we can see here. Question number 6. A weightless beam balance. He just wants to make sure, when he says a weightless beam balance, he wants you to stop thinking about the weight or using weight as another force in this system. So whatever forces the system has given to you, that is P, Q, and R, are the only forces in this system. He wants you to make an equation for the system to be in equilibrium, and that would be very straightforward. So we have P into D, or you can say from the point of action of the force up to the pivot. That is the rule for moment, and moment is equal to force into distance. In these cases, it's very easy to figure out where the force is, but it's difficult to figure out the distance. And always remember, distance for any force in this formula will be from the point of action of the force, wherever the force is acting, up to the pivot, irrespective what any other forces might be involved in the question. It's not my problem. So for P, I can see that it will be very clearly P into D. For Q, I can see it will be Q multiplied by its distance up to the pivot, which is B. For R, again, I can ignore everything else and I can realize that this should be R multiplied by A from the point of action up to the pivot. Now, in this case, we need to realize that what every type of moment is trying to do. Is it trying to go clockwise? Is it trying to go anti-clockwise? This is what we have to be careful about. So let's figure out the moment produced by P is anti-clockwise, and the moment produced by Q is clockwise. The moment produced by R is also clockwise. If you extend the arrow, you will realize that it is trying to rotate in the same direction, or it is trying to help the moment produced by R. So I can say that all the moments that are causing anti-clockwise moment should be equal to all the moments causing clockwise moment. And this is exactly the definition of principle of moments. The sum of clockwise and sum of anti-clockwise moments are equal to each other. So P into D is equal to the sum of Q multiplied by B plus another set was R multiplied by A. So this will be R multiplied by A. Now you won't find this in these equations. What you will find is a rearrangement of Q into B brought to the other side. Now there's another way to look at this. It's very simple. You see what he has done is trying to divide the whole system around the pivot. So since Q was in the opposite direction to P, they've added a negative sign in the correct option. And of course, the correct option is option D. They've added a negative sign. What you could have done is you could have solved it very simply for yourself by taking everything on one side, being clockwise and anti-clockwise, separated on left-hand side and right-hand side, and then bring this to the other side. It will again give you P multiplied by D with a subtraction, because this whole was positive, with Q multiplied by B being equal to R multiplied by A. Again, you land at the same equation, doesn't matter. Question number 7 says an object is moving at 3 meters per second. Now pay attention to the positive 3 meters per second, because that generally means it's going to be the right direction or the right side of the movement for this object. So I can visualize that this object might be moving towards the right side with a speed of 3 meters per second, and a force acts on it, probably bounces off a wall, probably somebody hit this object, and now it is moving towards the left side, showed by the negative sign, as 4 meters per second. This is the visualization for this. The mass of the object is 5 kilograms. He wants you to find out the change in momentum, which is definitely be change in momentum equals to final momentum minus initial momentum. Now, please be advised, please be very advised, the word change that we so generally use is what this negative sign is coming from. So we're translating English into simple mathematics. The signs of the vectors are a separate issue. The sign is because of the English that we are saying we are taking change in momentum. Now, the final momentum is because of the negative value. So it will be, the final momentum will be minus 4 multiplied by 5, which is the mass of the system. Minus, now be careful, the original or the initial velocity or the initial speed was positive 3. But this negative sign, that is because of the formula, will change the whole bracket to a negative value eventually. But I will still write down 3 multiplied by 5. So this eventually comes down to negative 35 kg meters per second. Now, what you could have done is, alternatively, some students, what they do is, since they know that the mass is exactly the same for both cases, they just deal with velocities first. So this would have been minus 4 minus into plus 3 multiplied by 5. So this would have ended at minus 7 multiplied by 5, again leading to minus 35 kg meters per second, which is again also a right approach. The answer of this question would be option A. Be careful. Question number 8 is about pressure. He mentions pressure indirectly, and then he says the density of the liquid. Very straightforward question. At the bottom of the liquid suggests it's actually the pressure at the base. So we'll be likely taking the full length of column of the liquid. So the pressure of liquid is rho GH. He's mentioned that the pressure of the liquid is 6,000 newtons per meter square. Now we know that newtons per meter square is actually what pascals is about. If you keep the formula of pressure is force equals to area or force over area, if you keep them in standard formats as SI standard units, then you can eventually call this as pascals, and that is what the extra added confusion in this question is about. So I don't have to change anything else. This will be 6,000. Density is what I need to find out, and the value of G is 9.81, or you can take 9.8. The value of H is 50 centimeters. Now again, be careful. The whole question is dealing with meter squares, and even the answers in the density are dealing with meter cube. That is a hint to you that all the distances or heights, lengths, parameters of lengths need to be converted into standard format. So 50 divided by 100, or you could have written down 50 into 10 to the power minus 2. This would give you density's answer to be equal to 1200. If you find exact answer, this will be 1224, but of course we don't have that liberty. We have to narrow down to two significant figures. It will be option B. Question number 9. Which statement correctly describes a change in state? And very easily we can see a gas condenses from a liquid would be the right answer. Other options are incorrect physics. You see, a liquid melts to form a solid. No, melting is when liquid is formed from a solid. A solid condenses. Condensation only takes place when a gas and a liquid is involved. So not possible. A solid boils, again not possible. So he's using wrong terminology for wrong situations. Question number 10. He says we have base of a metal pan. We have the handle of a metal pan. A very classic common question in terms of what type of materials should be used for these applications. So the base of the pan should definitely be a good thermal conductor, and the handle should be a poor thermal conductor, so that heat from the pan does not get to our hands, and it is easy and safe for us to handle while we're cooking food. Option B seems to be the right answer. Question 11, he says a solar heating panel consists of pipes carrying water to absorb radiation from the sun. That is very, very easy. So and now this question is again a classic repeated question. He wants you to understand what texture you would choose versus what color you would choose for what? For the quickest rate of absorption of radiation. So we understand that radiation is absorbed very quickly in a black surface. But what type of texture should we choose? Should we choose dull or shiny? We will be choosing dull texture, and the quickest rate of absorption and emission would go to dull black surfaces. Now, why did we avoid shiny surface? You see, radiation from a shiny surface will get reflected. Now, since there is an off chance of being reflected or reflection, the object it is reflecting from would be absorbing less radiation. So that is why we would want dull surface, so that it absorbs everything, and gives out nothing. Question number 12. Which pollen grains in water are viewed through microscope? Again, a very classic question. They are seen to be in continuous rapid motion. The convection, there are no convection currents unless there is a difference of densities involved, and this only happens when you try to heat up a liquid. Bombardment by a single molecule of water? No, there are multiple molecules from left and right. Uneven bombardment seems to be the right answer, and this is closely related. Collision with another pollen grain, no. The idea is that pollen grains cannot move on their own. If that is the case, or if that would have been the case, if we had a container and we just added pollen grains in the container without any liquid addition, without any liquid, they're still going to stay there on their own position. But when we add water, we see these pollen grains move ever so slightly. They continuously keep moving left and right, and that is why the reason it's so, because water molecules are moving at all times, and when they collide with these solid molecules, the solid molecules appear, or the solid particles appear to be moving, which gave us the guarantee that definitely liquid particles are always in random and rapid motion. So this option seems to be option C. I will try to add a bit of, and I will try to show an animation for that. Let's try to go towards that animation. So this is what pollen grains would look like to your eyes under the microscope. Now, again, this is highly magnified and this is highly exaggerated to make sure that the effect is visible to your eyes. Now, let's see how the pollen grains react when they are inside water. We can see that they are very slightly, ever so slightly moving left and right and so on and so forth, which we wouldn't have been able to see if there was no water. Now, if you zoom in further down and you just try to animate this in 3 dimensions with other things, the blue dot represents the pollen grain and the white and the red ones represent water molecules. And observe that it is being hit from all directions very randomly, and we are very unsure and unclear where all these particles will end up, and we can't predict them. So if you notice, this is exactly the same. These are exactly the same statement that he is using to describe option C, and this is exactly what happens in water, or in liquid, to be precise, and to be for that matter. Moving on, we have question number 13. Says circular flat bottom dish contains 100 cm cube of water. He wants to make sure the water evaporates and how to increase the rate of evaporation. So flat bottom dish of a large diameter. Yes, if you do this, for example, if you had a dish like this and you have increased the diameter, you're primarily increasing the surface area. And if you increase the surface area, definitely the rate of evaporation increasing. The second one, cool the dish in water. We're trying to increase the rate of evaporation. If you cool it down, it has the opposite effect. You see, evaporation depends on temperature, but inversely. So if you reduce the temperature, so the evaporation also decreases. So we want the, it is directly related. So temperature is directly related to evaporation. If you decrease temperature or cool it down, evaporation decreases. If you heat it up, the particles have more energy to escape and they can escape more easily. So second change, or the second student's effect, would not be good for increasing rate of evaporation. Student 3, create a current of airflow. So this is also going to increase evaporation, primarily because if you increase the airflow, then whatever particles have escaped and are existing partially over the surface or over the liquid on the outside, they will be swept away, and there will be space for new water elements, water particles to escape. And if you talk about these particles individually, this is what we call as humidity in air, the presence of water molecules in air. So question number 14. So the answer for this question number 13, will be option C, as 1 and 3 are only effective. Question 14. Matter consists of very small particles in continuous state of motion. We understand that. We should describe behavior of liquids. Now he's going to be emphasizing on liquid because this is the most confusing. Now forces of attraction between liquid is very strong. You see, if we draw a spectrum from solids to gases, we believe generally, again, it's a misconception, that liquids may be somewhere in the center, but that's not the case. Liquids are very much close to solids, so their properties resemble solids. They are incompressible. They are very strong forces of attraction. The only problem is that they can't form a defined shape, and it is only because 1 or 2 bonds are missing as compared to solids. So they're very close to solids in terms of their properties. So the particles can move randomly. They can move randomly. But if you talk about high speed, then in terms of the movement, it's not as high as it might seem, because speed is related to temperature, and there has been no reference to temperature in this question. Other than that, the forces are going, they do vibrate on their fixed positions, and they try to do that, but they do change positions. Solids vibrate, but they can't change their position. That's why we say they're doing that in fixed position. But this is a question that works, or that tries to dig deep in terms of the vocabulary that you're going to use for these questions, and the option B will be the right answer. Question 15 is about heat capacity and thermal energy and so on and so forth. We understand there is a power supply, an ammeter, a thermometer, and a heater. He says the table gives the results of the experiment. Okay, fine. And I think they're going to find the heat capacity probably in this experiment. This is a classic ATP question. So the heat capacity, so heat capacity is already given. What is the maximum possible temperature rise in the block? No problem. Now, notice that in this question, you will get confused by the word temperature, because there is no initial temperature given, there is no final temperature given. So that's not my problem. That's not our problem at the moment. Why? Because he's mentioning temperature rise. So initially, or primarily, he's talking about delta T, or change in temperature. So we don't need to worry about that. We just need to worry about the fact we need to figure out what goes where. So Q equals to MC delta T. Q is the energy supplied, and that has been done by the electric heater. So if you go back in terms of power equals to energy divided by time. And if you bring time over there, this becomes power multiplied by time equals to energy from the electric heater. And this is universal equation for energy and power. And we understand that electric power is P equals to IV, current multiplied by voltage. That's why current and voltage are mentioned to you. So if I place them over here, this becomes IVT equals to energy. Now, since we didn't have a stove to do that, we had an electric heater. This energy is being provided by the electric source. So this will be IVT equals to MC delta T, and delta T is what we want to find out. So current is 5 amperes, so this will be 5 multiplied by 12 multiplied by done for 300 seconds. T is time. M is mass. It's probably given somewhere in the question. Yes, it's 0.8. So this is 0.8 multiplied by specific heat capacity, which is 900, multiplied by delta T is what we are trying to find. So delta T comes out very clearly as 25 degrees centigrade. If the question had been regarding Kelvin, the change in temperature would still be the same, because the change in Kelvin is equal to the change in degree centigrade, despite them being linked by an equation that Kelvin is equal to degree centigrade being added with 273. The idea behind this is that since it's a linear relationship, it doesn't have any powers. Whatever happens to C happens to K linearly. So the changes are basically equal, but with a difference of 273. So it doesn't matter. If the question was with Kelvin, you would still end up with the same value. And of course, it's quite possible that the 900 joules, or it may be slightly different, because Kelvin and degree centigrade are primarily different scales, but at IGCSE we consider them to be equal. Question number 16. Simply, we have to choose what's going to be amplitude, what's going to be the wavelength. We understand that Q represents wavelength, P is representing nothing, R is representing the amplitude. So, which describes, okay, so P should be, P is not the amplitude. It is not the amplitude. S is not the speed. P is not the speed. So Q is the wavelength. R is the amplitude. Q is the wavelength. R is the amplitude. And S is not a wavelength. It's half a wavelength. So the best option will be option C. We move to the next question. That is question number 17. He says, which row describes characteristics of the image formed by a plane mirror? Again, this is a classic question in terms of memorization, in terms of rote memory. I can't really help you in this one. You have to just memorize what the properties are of a plane mirror. So it's generally virtual, and it is generally same size. It is one of the properties. So one of the properties that's missing is that, for example, if this is the mirror and you're standing in front of it, when he says size, it means the height. But if you go a bit deeper, it definitely means the physical dimensions in all three dimensions will appear the same. And the third thing, or the third property that's missing, which should also be memorized, is the distance. If this is the object, if this is the real you outside the mirror, then the person that you see inside the mirror, the image of the object on the outside, should also have the same distance from the mirror. So if this is the distance of the real object, then this should be the distance of the image. If this is, let's say, 5 meters away, this will also be 5 meters away on the inside of the mirror. This is the third property that you have to memorize, this apart from these two for a plane mirror. Question number 18, and this will be option D very clearly. Question number 18. Now, this is a bit tricky. Okay, so we have in order to do that, I would advise you to write down these things on a number scale. So this is 10 hertz and goes up to let's make a scale for this. So this is 10 hertz and this goes up to, let's say this is the extreme. The highest we have in this question is for the horse, let's say 33,000. Let's make it another way. So if we have a number line, or if we make a number line like this one, let's say this is 0 hertz and this is, let's say, 35,000 hertz. The elephants would probably be hearing from, let's say, 10 hertz up to 12,000 hertz. This is the elephant. If you can do this mentally, that's completely up to you, it's fine. Horses can go from, let's say, 55 hertz up to 33,000 hertz. And human hearing goes from 20 hertz, which is going to start right about at the center, and goes up to 20,000, which is more than elephants, but much less than horses. So this is the human ear, this is the horse, this is human, and this is horse. Now let's read the statement. It says, human ear can hear all sounds. When he says all, that means that all range of frequencies are available to us, which is incorrect. We can't do that. Human ear can hear all sounds. No, we can't do that. Human ear can hear all sounds. No, we can't do that. Human ear cannot hear all sounds. Yes, this is a bit true. Heard by elephants, nor heard by horses. Yes, this makes much more sense because elephants can hear low than below 20 hertz, which is our range. And horses can go beyond 20,000, which is much more than what we can hear. So option D looks like the most plausible option. Question number 19. An object is placed in front of the mirror. Which ray diagram would be the most appropriate? So the first thing we do in these questions is that we measure the distance from the object and we measure the same distance inside the mirror and place the object over there. So this will be my image. So the image has to be directly in front of the object, which appears to be only option A. But let's explore this further. So when you draw this one, how do you get the person whose eyes are going to be here to see this? You see, the light rays do emerge or appear to emerge from that object, and since this is the virtual side of the mirror, it is supposed to be having, or is supposed to have, dotted lines to separate the virtual side from the real side. You see, the real side will have solid lines plus the arrows. So this MCQ is not only a question, but it's also a guide if you get the same question in P4 or structured question. Question number 20, very straightforward, very simple. We have to apply the refractive index formula, so that would be simply n equals to a rayed medium or sine of angle in the rayed medium divided by sine of angle in the dense medium. So the angle in the ray medium should be this one. It should be 90 minus theta 1, and this will be straightforward because all the angles are measured from normal. That's why we draw the normal in every question, because these formulas are for angles measured with the normal. So this situation or this question will be very simply sine of 90 minus theta 1 divided by sine of theta 2. So that is option C. This is equal to the refractive index. Let's move to the question number 21. He says the speed of light on the outside is 3 into 10 raised to the power 8 meters per second. This is the incident wave, and most likely this is air, where the speed of light is maximum. Even more so than this, it will be in vacuum. So undergoes refraction, shows okay, fine. He says what's the speed of the... Now we have two formulas for refractive index. So the first one is what we did in the previous part, which is sine of I over R, which is primarily rare, divided by sine in dense medium. But we also have refractive index equals to C divided by V. Now C is the speed of light in air, the maximum speed, and v is its speed in that medium or whatever medium it's trying to go to. It could be through perspex, could be through plastic, could be through other materials. So v would be its speed in this medium and c would be its speed in this medium. So we don't have the refractive index directly, so we are given the angles to do that for us. So n is equal to sine of 55 divided by sine of 33. Again, how did I choose 55 and 33? To common person, it might look very simple that this is angle of incidence and this is the angle of reflection, but be careful. I'm referring to rare divided by dense. I'm not referring to where they're coming from and where they're going. We will encounter this problem when the light ray is already in glass or in a dense medium. You draw the normal and it bends away from the normal with, let's say, air. Now, when you measure the angle, let's say this angle is 30 degrees and this angle, let's say, came out as 57 degrees. If you try to do the same strategy with the sine I divided by sine R, this is I and this is R. You will get the wrong answer. So to avoid this problem, it's always going to be rare or less dense divided by more dense. The actual theory behind this is going to come from Snell's law, but since we're not doing that, I'm just showing you a shortcut or a trick how to do these questions. And why do I always prefer rare over dense? Now, when you solve this question, you can equate the value to directly c divided by v. Now, this should be 3 into 10 raised to the power 8 divided by v. Now, simple algebra of v leads to 1.99 into 10 raised to the power 8 meters per second, which is definitely going to be option B, very clearly and very simply. The question number 22 states we need to provide some correction to a person who is going to observe converging lens So what converging lens and diverging lenses are used for? Again, question from memory. So converging lenses always produce an inverted. They don't always do that, but they generally do. Can we use a magnifying glass? Yes, that's true. Correct short-sightedness? Not so much, probably. Yeah. Yes, they can produce a virtual image, but this is purely in the case can produce real and virtual images. Yes, they both can do that. Converging lens can do both jobs, but virtual image is only in the case of magnifying glass. So, and the third one, diverging lens can focus. No, they can't focus that. Do not have a principal focus. They do have a principal. No, sorry, they don't, but they do generally. They don't have a principal focus. Yeah, they don't. So where are usually thinner? We can't say that. Can be used to correct short sight? Yes, we can. So option D will be the right answer. Let's move to question number 23. We have a very interesting question. If you notice, the bar is already placed in its own position, but when you bring another bar close to this, the mass appears to increase from 45.3 to 45.7, which means that the X bar has experienced a force downwards. Now, it can only happen if both rods have the same charge. Only then they will experience repulsion, or enough repulsion that X gets pushed down. Because whatever weight it had, let's say if it had some weight mg, it is already displayed on the electronic balance, which is 45.3. This change is only because of the influence from the outside. So I'm expecting to produce like charges or similar charges. It could have been positive, or negative, negative. I'm looking for these answers. So negative, negative, good. Negative, positive, no. Negative, no charge, no. Positive, no charge, no. I need similar charges. It should be option A. 24, unit of potential difference. Classic equation from the syllabus, work done by charge. This will be joules per coulomb, or simply called as volt, which is option D. Question number 25. Transformer question. He says 500 515 output voltage, classic step down transformer. How do we know that? Because the input turns are greater and the output voltage turns are less. So this is a step down transformer, although not mentioned in the question, but as a source of revision we can do that. So using the equation Vs, or secondary, or the output voltage, divided by the input, which is primary, equals to number of turns of secondary divided by number of turns of primary. Let's put in the values. So voltage of the primary is 22,000. That is what we're giving at the input. Number of secondary turns is 115, and number of primary turns is 550. Now, when you bring 22,000 to the other side and perform the algebra, you will find that this answer comes out as 4600 volts. And it's a very rounded answer, so this will be option C. Question number 26. It says we have two diagrams, and we have 3 points, P, Q, and R. He wants to find the weakest magnetic field and the strongest magnetic field. You see, between the diagram 1, if we try to draw the magnetic field, since they are like poles, the magnetic fields do not interact with each other. They are actually moving away from each other. This is pointing out, and since we know North Pole was going to be pointing out. So point P experiences no magnetic field or nearly zero magnetic field at best. So the weakest field should be at point P. And now we have to make a choice between Q and R. So if I were to make a magnetic field from N from diagram 2, so it should go something like this. Since they both attract each other, their magnetic fields interact. So it's from north to south like this. Now, since I don't have a choice to do it at north, I have a choice to do it at south or at the center. I can see that the lines are spacing out when they reach Q. And this is how it is. The lines get very close to each other when they reach S. Now, this is one of the guarantees, according to the book, that if you want to represent a strong magnetic field, the lines that you draw should be close to each other. And that is exactly what is going to happen when you're close to any pole, not just south, but any pole. They're also stronger here as well. But since that point isn't mentioned, we'll have to make a choice between R and Q, and this will be R in our case, which makes B option the right answer for this question. Let's keep moving. To 27, he says, now this is a repeated question. There are multiple ways to solve this. There's a ratio method. There is a mathematical method. Whatever you choose to do with this question, it's completely up to you. Now, I would like to show you a trick for this question. Whenever you are dealing with diameter, not area, but diameter, there is a ratio between them. And where does the ratio comes from? So cross-sectional area, which is, of course, resistance equals to rho L over A. Now, this is the formula. This is part of this formula, so I'm going to talk about that. So this becomes pi d squared divided by 4. Let's ignore pi and 4 for now, because they are constants. They are not going to be involved in any mathematical calculation involving ratio and proportions. So cross-section area is directly proportional to d squared, which means that if diameter is 1, area is 1. If diameter is 2, area is 4, because it is being squared. And if diameter is 3, then the area is 9 times. Now, if you observe, the diameter has been doubled, which means that if you double the diameter, the area has to increase by 4. If this has area A, this would be 4A, or 4 times more than that. So if you put all these variables, and the length is given straightforward. So if the resistance of wire P as P, whatever standard that may be, was, let's say, X or this much, which was, of course, equal to rho L over A. Again, if you replace the values with 1 meter and 1 millimeter, you will get complicated long decimal answers, but we're not here to do that. We're just here for comparison. And then RQ equals to whatever that may be equal to rho. Length has been doubled, so I will add a 2L divided by. Diameter has been doubled, so area would have been 4 times, so this will become 1 over 2L divided by A, which is rho L over A. Now, since they are being made from the same material, nichrome and nichrome, I will not be talking about the value of rho, because rho is resistivity, which is dependent on the type of material. And since they are both having the same material, talking about it or involving this in mathematics doesn't make any sense. So this is what we are left with. So whatever resistance of RP must have been, RQ is exactly the half of that resistance. So option B seems to be the right answer. You can involve these values. You can find the rho. You can go the long way by using pi d squared by 4. You're most welcome to do that by 4 by adding this and then into 10 raised to power minus 3 and then taking the square, going the distance. I'm completely fine with that, but you will find that it's much more hectic than this. I would much rather advise you to use this technique. Question number 28. He says a student has 2 resistors. Okay, fine. 2 ohms and then 40 kilo ohms. Now this is a tricky question, and they are connected in parallel. If you connect them in series, the resistance has to be much greater, or resistance has to be at least greater than 40,000 ohms. he makes a mistake deliberately by not adding the kilo in this, just to test you that have you ignored the kilo in this question. And also, the combined resistance would be an addition, so it should be greater than 40,000. So C and D are not even possible, even by a margin or even by a misconception. Now, if I were to solve this question by a parallel combination system, that would have been 1 over 2 plus 1 divided by 40,000 equals to 1 over R, T as total. When you find this answer comes out as 1.9999 and so on, which up to 2 significant figures will be rounded off as option B. So most of the students would have gotten this answer correct as parallel and parallel, but they might have landed at 1.9, but they should have done it as 2.0, because we understand that we choose 2 significant figures above everything else. You see, if you had selected 2 significant figures, you would have made sure, what you've tried to make sure is there any rounding off involved? And the answer would be yes. And if there is, then you have to convert this into 2.0. So by that method, it would be B. But again, be careful. Question number 29, we have the action of a diode. He says, which circuit do both lamps light? So current needs to pass through both of them. So this is plus and this is minus. The current wants to go this way. The diode is in the opposite direction. No current flows. This will be off and this will also be off. The supply is not connected to any of the bulbs. Positive, negative. If we try to test the direction of the current, it is again opposite to the diode. Both bulbs stay off and this will also be off. Positive, negative, current tries to enter here. Current can go to this bulb. Current can go to this bulb. The arrow direction matches the diode. This is how to remember that. So this will be on and this will be on. Option D, this is positive and negative. Current is going through this bulb. It will be on. Current tries to go here, but cannot go because the direction of the proposed direction of the current due to the battery and the diode, the direction of the diode is entirely opposite. So the current cannot flow. So this bulb will be off. So both of them cannot light up in example D and A and B. So only right answer is option C. Question number 30, again, the way I've explained this question is not scientific. As I've told you, the direction of arrow is only for a test. The current does not flow in this branch to begin with. It's not that the current comes at this junction and then flows through the bulb and then reaches this point like a traffic example and then realizes that the bridge is closed. No, the current would not even enter. So please keep in mind that this is just a model. This is just a way to explain the question. This is not entirely scientific. Now, question number 30. An isotope of strontium has a nuclear notation. This proton, very straightforward question. No questions are. Protons are the number written at the position 38 at this position, and neutrons are found by subtracting these 2 numbers. So this is A is equal to 84, Z is equal to 38. This is representing protons, and this is representing protons plus neutrons. So if you want to represent these numbers, then they should be subtracted. If you want to find neutrons, it will be subtracted. Now, what I will do, we can do this over here as 84 minus 38, but you have to be clever to save more time. Since you know that option C and D are not possible, we are not going to check them or even look at them because we know protons are going to be 38. Do I really need to subtract or go through with the subtraction because the other number is 84? Can it be 84? No, it has to be less than 84 because 38 will be subtracted from it. So it should be 46. So if you go by that logic, you will immediately realize without even touching the calculator that it's going to be option A. But if you want, you can go the distance of actually doing the calculation. So question number 31, a student is investigating the count rate of a radioactive substance and he says, what must be adjust his reading, and that is for the corrected count rate. And I'm mentioning the topic so that if you want to go and revise something regarding that, you can. This is from the corrected count rate topic. Okay, so he says add the background count to his readings. No, we don't do that. We actually do the opposite. Ignore the we can't ignore. We can't ignore. Subtract the back. Yes, this is what we do. Take repeated readings. We can't do that. You see, the background radiation is always there. Even if you repeat the reading, it will still be a part of the reading. So the best way to go about this is subtract the reading at the start of the question and then add back the value at the end of the question if he asks you to find the reading of the GM tube, not of the source. So C seems to be the best answer. 32. What occurs during nuclear fusion? This is a factual question. This is a fact question. Again, I can't help you more than this. It is option A. They will be joining together. They don't absorb energy, they release energy, and that is exactly what is happening at our sun. Question number 33. A beta particle enters a uniform magnetic field directed. Okay, fine. So if you want to go through with this question, you need to realize we can use Fleming's left-hand rule as an instinct, but this question probably isn't about that. So which direction? Oh, good. So which direction the electric field has to be so that the electrons would also deflect electrons downward. So apart from the addition of magnetic field, if you use the Fleming's left-hand rule, you will realize that the thumb points downwards, or eventually is going to be downwards for the electrons. But what can we do further in terms of electric field? This is a negatively charged particle, so that we can make sure that it still keeps going down. Now, if I had to add an electric field, I would make sure that a plate or something at this location should be positively charged, so the electron gets attracted. And somewhere over here, there should be a negatively charged plate, or a plate that is at a lower potential. Now, be advised, I just added benefit of doubt. Negative potential or negative voltage doesn't have to be negative in its own self. It just has to be less positive than the other one. So, for example, if this is 500 volts, positive 500, and this is just positive 300 volts, this will still be considered a negative plate, or a plate that is at a lower potential and would do the job. For example, if this was, let's say, 500 volts and the other plate was minus 350 volts, that will still be negative because it is very obvious that it's a negative potential. For example, if this had been minus 500, then this one has to be more negative than this one to be qualifying as positive or negative. So please be advised, we are looking at it from a numerical perspective, but it's not really required over here. So he says which direction should be the electric field so that this happens. So I've drawn the expected direction of the plates, but the electric field is always from positive plate towards the negative plate. So it seems to me that it should be into the page, out of the page. No, nothing in 3 dimensions. It should be down the page or up the page. It is up the page, so it should be option D. Yeah. 34. He says radioactive isotope is this alpha emitter, which is 42. Polonium. How many neutrons does it have? So very straightforward. We can write a decay equation for this. So Rn 222, and this is 86, becoming polonium with alpha, which is 42. So it's just a matter of algebra. We realize that 222 minus 4 gives me 218, and 86 minus 2 gives me 84. Since we're interested in the neutrons of polonium, we can now subtract 218 from 84 because this is what we know today. So it's a 2-step question. When you do that, it's going to be 134. Which statement gives 2 safety precautions to take when a person is working with ionizing radiation? Okay, so decrease the exposure time. Yes, that's a good idea, but this is what we wanted to do, decrease the exposure time. We don't want to increase the exposure time. We want to stay away from the sources as much as possible. In terms of exposure, decrease the distance, not really. We want to stay away from them. We increase the distance between the person and the source. So option B seems to be the right answer. 36, again, it is from memory. It is from a simple fact. I can't really help you with that. It says which order correctly, decreasing order of distance. So it has to be option C, Neptune, Uranus, Saturn, and Jupiter. Again, I'm really sorry, can't really help you with that. It's just a logic. It's just the way they've been named. Question number 37, he says, the radiation we're receiving from the sun, it is broadly divided into 3 spectrums. Which one is infrared, visible, and so on and so forth? So, which one is region 3? It's fairly obvious at this point. Again, it's from memory. And again, this is a repeated question. You don't expect this question too often, but it is a repeated question in hindsight. So number 1 is purely infrared radiation. Now, infrared radiation is what causes the heating effect because of the sun. Number 2 is the light, the visible light that you see or the sun enables you to see. The third one is actually the ultraviolet radiation. This is what the ozone is fighting with or is trying to reduce so that you don't get cancer, God forbid. But if you really want to go into the percentages, this is roughly 10%. This infrared is roughly, I think it's approximately more than 55 or 60. Let's make it 60%. And the light is 60, 70 is around 30% of it. If you go online, you'll search and you'll find out that there's actually 1%, very tiny, less than 1% of X-ray as well. But since it is too low in its concentration or percentage, we generally avoid talking about it because we understand that an IGC student would be more familiar with the UV, infrared, and light, visible light. So the option for this question would be ultraviolet. Question number 38. He says the diagram shows a comet moving through an elliptical orbit around the sun, which position moving at greater speed. Now, this is interesting because if you notice, this is where the comet actually starts moving from generally, if there is a comet. So since it's moving away, we say that it is like you've thrown an object away from the sun, or you've thrown an object away from the surface of the earth. What happens when you do that? A common analogy would be, if you're standing here and you throw an object upwards, it is being attracted by the earth's gravity. It will slow down while going up or going away from the earth, and then it will start falling down again. This is exactly what happens when it starts moving away from the sun. Its speed starts decreasing, its kinetic energy starts decreasing, but its gravitational potential energy starts increasing because it's going away. So if I were to apply the formula, I can say that for the gravitational potential mgh, this whole length becomes h. And when it starts falling back down again, the gravitational potential energy is now being taken from gravitational store, and then being given to the kinetic store. So as it falls down, it is unable to fall onto the sun primarily because of its speed. It is moving at such a high rate of speed, it doesn't give or doesn't have enough time to fall into the sun. Rather, it overshoots and then goes back to its own path again. So I suspect that the highest energy it will have in terms of its speed should be at point A. And that is our right answer. That is the way to think about it. Question number 39. Nuclear reactors in the sun release large quantities of energy. We understand that. It involves fission. No, it doesn't. It involves fusion of hydrogen to produce helium. Again, it's a fact. I can't really help you with that. It's how a star is being formed. Question number 40 is again a memory-based question. He says, mean surface temperature, Earth, Uranus, planet X, planet Y. We are supposed to name a planet X and Y. So if this is my sun, then the next planet we have is Mercury. Then we have Venus. Then we have Earth. Then we have Mars. Then we have Jupiter. Then we have Saturn. And then we have Uranus. And then we have Neptune. Pluto sadly has been jumped out of the planet list because we don't like Pluto. Now, the general trend is as you move away from the sun, the temperature decreases because you get more colder and colder. So if Uranus temperature is mentioned as minus 195 and there is 140, which is colder than minus 65, then I'm expecting that it should be either Saturn, Jupiter, and so on. So the question mentions Mars, Mercury. Now, Mercury is impossible. Mercury is the closest one to the sun. It's really hot. So Mercury is not in the question. So C will not be my problem. C or D will not be my question. So I have to make a choice between Mars and Saturn and Neptune. So planet Y is colder, so it should be closer to Uranus. So is it Neptune? Nope. If it had been Neptune, it must have been even colder, let's say minus 250. So it's not Neptune. It should be Saturn and Mars. So this is our prediction. This is option A. Again, the trend is that as you go away from the sun, the temperature gets colder and these planets are much hotter as compared to the other ones. That is all for today. I hope you understand a few things about IGCSE. I'll see you in the next one.